Good day to everyone. This is a recorded lecture on quantitative data analysis, albeit this would be a generic discussion, but we will be focusing on those most frequently and most commonly used statistical tools. Okay, so to start with, this would be somehow a flow of the discussion. Um, so that we would understand the results, we would have first that understanding of essential concepts needed so that we would better and fully understand everything, and then prepare for the data analysis. Then you would now perform, and we would now perform the analysis using the software and interpret the results. Just to put things into context, what we need to understand is that although we are not really aiming to become statisticians or experts in statistics, but it should not be viewed as separate. Statistics and research should not be viewed as separate. It should be statistics in research. So everything that we should be discussing are on the context of research. Only those concepts that would be crucial and useful when you would be engaging in a research activity. Statistics as a separate field may be a different set of concepts and concerns which may not really be customized for research. But in our context, in our discussion, when we talk about statistics, it's not just statistics as a separate science. It would be statistical analysis to aid in research activity, primarily on the data analysis for a quantitative research. And there should be a basic understanding on research and on statistics. It's crucial. Again, we are not really aiming to suddenly become experts after the course, but part of being researchers is that you should ask the question why. And one big question mark in the research components really is on the aspect of statistical analysis and how you try to interpret and you arrive at certain conclusions. And you should own your research. Therefore, it is imperative, it is required, a mandate for you to have that basic understanding. Okay, and the research statistics need not to be difficult. Okay, although not all people love numbers, but since we are engaged in research, we need to love numbers. And when you would begin to appreciate the how easy it is to do statistical analysis, then you would view research statistics as a useful subjects more than being a burden, but it's more of aiding us to arrive at better results. And we need to challenge conventions. Okay, even if they are spelled out in books, but many books which serve as references for statistical analysis authored by Filipino um, authors are not really tied to its use in research. It's more of a separate entity of elementary statistics, whatever statistics those may be. But in the language of research, they should be presenting it in the language of research. Okay, and there are so many practices that have been persistently occurring. Even if they are wrong, they are still being promoted and they are still being followed simply because not all of us dare challenge those authorities. And who are we to challenge if we only have very limited knowledge about research statistics? When we try to challenge, we try to improve what is existing as a source of knowledge so that we would also eliminate the threat. The threat is that what you are taught, if it is wrong, and when you would be the ones teaching, then you would also be teaching those wrong ideas and concepts. And it would be a vicious cycle. If no one would dare challenge, then we would fall into the trap of believing that everything is actually correct, even if they are wrong. And it's somehow connected with learning is something continuous. Okay, you are taking higher courses, higher subjects for higher degrees. It's because you want to satisfy your thirst for knowledge, for learning, and this is really part of it. Okay, so providing an overview of everything, you should understand that the research process is not composed of segmented steps. It's interrelated, from how you arrive at your topic, to developing your design, to data gathering and the analysis, and formulating conclusions, to publishing and presenting the results of your study. They are interconnected. And even if we would focus only on analysis for our discussion, we should understand that everything are put or should be understood and viewed as a part of a whole, and that whole is the research process. Okay? Specifically, trying to establish interrelationships. When you talk of theories, those are really very important elements if you would venture into a quantitative research. You could not and you should not, okay, do quantitative research having questions that would require hypothesis if you don't have a clear theory to begin with. Hindi po dapat na meron ka ng hypothesis and so on, and even analysis, and in the end you would be asked by the panelists or even other research experts to look for a theory that would suit your study. Baliktad po yung ganong pag-iisip. You should start with a theory. It's because you would want to challenge or you would want to confirm the theory. That's the reason why you are gathering the data, so that you could either accept or reject the hypothesis which is tied to the theory. The theory would now produce, would be the basis for you to draft your paradigm, the specific variables and indicators, and establishing their relationships. Then you would have your SOP based on what you have displayed in your paradigm. And based on the SOP, then you should know what should be the tentative answer to correspond, to respond to the SOPs that you have. Based on your hypothesis, mainly based on your hypothesis and your SOPs, you would be able to determine which is the best design, most appropriate design for your study. And in the design, it would also include the design for analysis, the planning for analysis. So if you could see down the line in the statistical analysis, you need to go back to the idea of the theoretical framework. Okay? And there are so many essential concepts, but we would just be trying to give an overview of this, since I would assume that in the previous lectures that I forwarded to you and provided you with, these were already discussed. Okay, talking about hypothesis testing, sample size and sampling techniques, even the levels of measurements and certain assumptions. These are key considerations so that you would know what statistical tool to use. It's another thing if you know how to operate, you know how to navigate the software, but if you had it wrong with regards to deciding on which statistical tool to use, kahit na po ang galing mo mag-navigate, it would never have and yield a correct answer. Okay? So, just a brief backgrounder or a reviewer of hypothesis testing. We understand that it's just like in court cases, wherein there would be two sides. One would push that the defendant is guilty, then the other would want to defend. Okay, but as a general rule, just like in court cases, the one accused is innocent until proven guilty. That's like in research. Okay, wherein when we make decisions in our hypothesis, it's actually connected to the decisions as what we do in court. When we say H0 or HO as a number, it's because it's null hypothesis. The defendant is not guilty. It's the same with saying that the hypothesis, the null hypothesis, is saying that the defendant is not guilty, or what you're trying to say is that there is not enough evidence to conclude that the defendant is guilty. On the other hand, Your alternative hypothesis H1 and the opposite of H0 or HO is when we say as our hypothesis that the defendant is guilty. Basically, what you're trying to arrive at is that you are like a prosecutor and you are trying to gather the evidence and you are trying to prove now and conclude that there is enough evidence actually to prove that the defendant is guilty. That's your main target. If you are the researcher, there is a question, you are actually the prosecutor. You are the one who is trying to collect the data so that you could reject the null hypothesis. Therefore, you could say that the defendant is guilty. Okay? Now, why state the null is because, yes, innocent, and then the burden of proof is on you. So therefore, you need to gather data, but the the weighing of the data so that you would say that it would be enough to prove the guilt of an individual should be beyond reasonable doubt. So in the language of statistics, the reasonable doubt would mean it should be not beyond 0.05, okay, as already beyond reasonable doubt. Okay. Now, in statistical hypothesis, when you say H1 or alternative hypothesis, these are samples. If your question is about relationship, then you would say there is a significant relationship between variables A and B. If you would ask a question about difference, then you would say there is a significant difference. If it's null, then it's the opposite. Okay, you're saying there is no significant relationship, there is no significant difference. If the question is about effect, the alternative hypothesis would be there is a significant effect. If it's null hypothesis, there's no significant effect. Okay. And when you make a decision, you would be basing it on the level of significance. In the social sciences, as what I previously have shown you, what is considered as beyond reasonable doubt for the social sciences is 0.05 and 0.01 for the natural sciences. So when what you have computed in your statistical analysis would be greater than the 0.05, okay, the doubt is not reasonable. Okay, therefore you have failed to reject the null hypothesis, or you may simply retain the HO. Okay, if it's lesser than 0.05, then therefore you should reject the null hypothesis and accept the alternative hypothesis. It's because the data, the evidence that you have gathered is within, okay, within that reasonable doubt. With regards to the errors in hypothesis testing, there will be two types, and these are important concepts, especially when we try to understand how we try to accept and reject a particular null hypothesis, and these are also concepts related to the computation of the sample size. Now, there would be two possible errors. One is when you reject an HO that's actually true in real life. Okay, it's just like saying that you are convicting an innocent person. That's type 1 hypothesis testing error. Sometimes we also try to accept an HO even if it's false. Okay, it's just the same with saying that you are actually acquitting a guilty person, and that's a type 2 error in hypothesis testing. One key consideration also when you talk about statistical analysis is on the question of sample size. Is it sufficient? And how you try to select the sample. And we are referring here to the sampling technique, and those are key considerations. Of course, when you talk of sample size, um, and you would be doing statistical analysis beyond the mean, median, and the mode, beyond central tendency, beyond descriptive statistics, then you should not be using Slovin's formula. If your study is just descriptive study, then it's okay to use Slovin's formula. But other than that, If you have a hypothesis, then definitely you should not be using Slovene as a justification at arriving at a certain sample size. Okay. What you should be doing, however, is statistical power analysis. So it's just a matter of combining many factors, like the effect size, like the tolerance for errors, like the statistical power, and the test that you would be using. These are considerations, and if you could note here, it is not considered as a factor the total population. So regardless of the total population, it should not be one of those factors in how you try to arrive at a certain sample size. Hopefully, you would try to erase that misconception. Okay. Now, how about sampling techniques? This is very important. It's because it is somehow connected to the idea of whether you should be using parametric or non-parametric test, at least in the initial phase. It's because there would be two general sampling techniques. First is non-probability and the other is probability. Samples of non-probability is judgment and convenience. Samples of probability are simple random, stratified, systematic, and cluster. Now, what would be the main differences between the two? Main difference. For non-probability, not everyone in the total population has that equal chance to be selected to be part as respondents. Whereas for probability, it's the other way or it's otherwise. Okay, in probability sampling, all members of a particular population are given that equal chance to be selected to form part of the respondents of your study. Therefore, if you'll try to compare the two, which is more reflective and representative of a given population, the sample that you would be getting, it would be more on the probability sampling. Okay, it has it increases a bit of ensures already that what you gathered as a sample, the responses coming from a sample, would actually be a true representation of the responses of the population, and it should be the case. Okay, another concern is about whether you would have a normally distributed sample. Normally, if it would be non-probability sampling, there would be bias involved. It may be that what you would end up is that you would be getting heavy on one part of a population or on the other end of a population. You won't arrive at a normally distributed population. Now, when you talk about normally distributed, it somehow really represents um, the the responses of a population. Okay, when you get a sample, if the sample would somehow form like a bell curve, and that's the standard normal distribution, therefore you are pretty much sure that what you have as a data are credible data that is actually representative of the responses of the population. Now, these are very essential concerns. Parametric or non-parametric, it's because many statisticians actually jump to using parametric tests. It's because parametric tests are more powerful compared to non-parametric tests. But what we should understand is that parametric tests should only be utilized when they are appropriate. It means that not at all times parametric tests should be used. Okay, so there is that concern of misuse of parametric tests. But what would be the assumptions? When should we be using parametric tests? When should we be using non-parametric tests only? One general, although it would vary from test to test, but we will be talking here about general assumptions. One is about normality of distribution. When you talk of normality, it talks about representation of data, and you could only say that the p-values, the the computation results that you would be getting would only be valid if it is normally distributed. Okay, it talks about when you say when is a certain sample response normally distributed, you think of two things: skewness and kurtosis. When you talk of skewness, it's the degree to which data departs from a symmetrical normal distribution. How far that is, does it deviate from the normal distribution? It should be symmetrical. Another is kurtosis. It's the degree to which values cluster in a particular area centering on the peak of a frequency distribution. These are some examples, common examples of the shape of a particular distribution. At the center, you could say that there is a normally distributed sample in here. Why? It's because it is symmetrical. The perfect normal distribution curve is when the mean is equal to the median or the mode, or at least they are near to each other. If it is heavy on the mode is greater than the mean and the median, and the median is greater than the mean. When the tail extends to the left, that's the tail, we consider it as left skewed. Okay, the concentration of the responses are on the right side. If it's on the right skewed, if we have the median is actually greater than the mode, but the mean is greater than the median. And the concentration of the responses are more on the left side. We call it right skewed is because the tail is longer on the right. Even if it appears to have a symmetrical distribution, there may still be a concern, and the concern would be about kurtosis, even if it satisfies the first assumption. Okay, kurtosis would mean whether it is leptocortic, mesocortic, and platycortic. In mesocortic, this would be on the zero. It's somehow on the middle part. It's not really peaking. Okay, the mean is not really too far from the rest of the responses. Unlike in the platycortic, the situation is different and the situation is opposite. Okay, the mean is actually nearer to the other responses. Okay, it's about flattened. Yeah. Now we also try to talk about homogeneity of variance. One consideration, one general consideration is normality. And you would be looking into the skewness and looking into the kurtosis. Those are two things under normality of distribution. Another is homogeneity of variance. It talks about similarity in dispersion pattern of data between groups being compared. Now, groups exhibit similar levels of variability. Okay, if you are trying to compare different groups, they may have differences, but their differences are not that far from each other. Okay. Now, what are the ways for us to detect whether what we have in the sample are or would satisfy the criteria of normality and homogeneity? The most commonly used tests are Shapiro-Wilk normality test, Kolmogorov-Smirnov normality test, and Levin's test of equality of error variances. It's as simple as depending on what would be the result of the computation, it would be versus 0.05 as always. Wherein your null hypothesis is that the distribution is normally distributed. You would be saying that the distribution has equal variances. But what if what you arrive as your computation is less than 0.05, therefore you reject the HO? Opposite of the HO is that the data is not normally distributed. If based on your computation using these commonly used tests in testing homogeneity of variance, if it's greater than 0.05, then you should not be using parametric test. Let me correct myself there. If the p-value is less than 0.05, therefore you should not use parametric test. If it's greater than 0.05, therefore you are saying that you are accepting the HO, therefore it's normally distributed, therefore you could use parametric tests. Okay, sorry for that confusion. Now, regarding the decision, how would I choose the most appropriate quantitative tool for my study? Okay, what are the other considerations? The level of measurement, how many variables are involved, and how the data are being prepared and being forwarded to you. If you are the statistician, if you are the researcher, how you try to prepare the data for encoding for data analysis, and whether it's parametric or non-parametric. Now, with regards to the levels of measurement, you try to ask yourself, what type of data would I be getting? These are all quantitative data. But there are some qualitative data that you should be treating as quantitative data for purposes only of categorization, and we call them nominal data, such as when you try to get the profile with regards to religion. Religion is not really numerical data, but if you would try to categorize data for purposes of categorization only, then you would try to label them as to 1, 2, and 3. Then these are just purely nominal data. Just like with year level, just like with a particular course, then you try to group responses based on courses and others. For ordinal data, you're actually trying to rank them. The typical examples for this is that if you would have questions in your questionnaire wherein you would have options, which among the following are the main considerations in trying to choose for a course to enroll in college, then you would have their 5 ready questions or options, and you would ask the respondents to rate or rank which is most influential, which is least influential. So with this kind of data, we label them as ordinal data is because we could actually order them. We could actually give them or provide them with sequence, but not necessarily that your first choice, the distance from your first choice to the second choice, is equal to the distance of your second choice to the third choice. It's just like in politics right now when you would be doing surveys wherein one would be too far from the rest, but and when you try to compare them, you would only be ranking them into first, second, third, and fourth. You could not determine really the distance between 1 and 2 and 3 and 4. Okay, but if it's ratio or interval data, there is actually a clear measurement of distance between one answer, one response, or one measurement to another measurement. You could actually compare them. And these are actually measurements, grades, performance. These are even height, even weight, and so on. It's because they are actual measurements. And you could actually compare them versus other measurements also. And this is a highest level or the complete analysis. Now, why are these important? But in the perspective of statistics, you may just try to cluster them into two. Either it's a discrete variable or a continuous variable. When you talk of discrete variables, these are countable. You could actually pinpoint them and count them with your fingers. And it could only take whole values. Okay? Individuals could not take 1.1 individual. Ang tao hindi po pwedeng hatiin. So, tao po ay number of people, discrete variables yung mga yan. But if it's continuous, they are not countable. Okay, you could not really place them in just purely whole numbers. They could take on any value. And it's simpler to categorize rather than on the three levels of measurement. Okay. Now, one consideration also is how many variables are involved in your study. If it's just one variable at a time, you may have many variables, but you do not make an attempt to cross one variable to another variable, meaning you would just be investigating one variable at a time. It's just univariate statistical analysis that you would be doing. If it's two variables at a time, it's bivariate, multivariate if it's more. Now, why is it important? It's because the type of test would also be dependent on the number of groups and the test to be used. Okay? Say for example, if your question, okay, one big consideration is what is the question for your research, for your hypothesis. The question is about difference. You're trying to compare. You're trying to compare males versus females responses, male versus female responses. But if it is non-parametric, meaning to say it did not really satisfy the two general assumptions of normality of distribution and homogeneity of variance, then you should be using Mann-Whitney as a statistical tool for two groups only. But if you satisfy those assumptions, you may use t-test. That's a very common test used for two groups. Take note, this is to answer tests or to answer questions about difference only. Okay, how about difference between or among 3, 4, 5? As long as they are more than two groups, if it's non-parametric, you have not satisfied the requirements for normality and homogeneity, then you should only be using Kruskal-Wallis. But if you satisfy those assumptions, then you may use F-test for it. Okay. How about association or relationship? Your question is about is there a significant relationship? Is there a significant association between one variable to the other? Then you would be looking into the level of measurement or the type of data. If you would have both nominal versus nominal, whether gender has something to do with religion, both of them are nominal data, then you would be using chi-square. Chi-square is a non-parametric test. There is no equivalent parametric test for it. If it's interval versus interval, okay, or continuous data versus continuous data, would the ratings of teachers be related to the performance of their students? But you have not fully satisfied the assumptions of normality of distribution and homogeneity of variance, then you should be using Spearman law. But if it's parametric, meaning you have satisfied the assumptions, you should be using Pearson R for that. Again, these are under the context of addressing a question about relationship. How about addressing a question about cause and effect? Then you would just simply use the regression analysis, path analysis for a different way of presenting it, but it would still yield the same result, or SEM and path analysis would have similarities. Now, how should you prepare for the analysis? The best way really is for you to plan ahead. Even if you are still on the phase of conceptualization of your research, you should already be aware of what tests to be used in the future. Say for example, your studies about motivation and study habits as predictors of academic performance. What you need to do is lay down all the variables of your study slash the SOPs. The first variable, general variable, is about profile. Second is about level of motivation. Third is about level of study habits. Fourth is about academic performance. And say, for example, you would have a question on trying to know whether there would be a difference in academic performance when you try to group them according to profile. You also have a question about whether motivation and study habits, this one, your second and third variables, would it influence or predict academic performance? That's your final SOP. These are all your SOPs for your quantitative research. All you need to do is try to determine what are sub-variables for each SOP. Okay, you try to lay it down here. And for each sub-variable, you try to identify what type of data you would be getting from them. Are they nominal, ratio, or interval, or ordinal, or ratio, or interval? In here, gender and course are both nominal, and so on. Okay, and what you should be doing is you try to code or develop or provide the scale, not really develop, but you try to inform us, provide the scales to be used. Okay, if it's nominal, if this is just gender, then it's really up to you whether you would assign male as one or female as one, and so on. It's just a matter of assigning. This is coding so that you would know what test to be used. Okay, for both gender and course, you would be only using frequency and percentage for that. Since here you have interval as a data and the responses would range from this, what you would be getting are mean, same with the level of study habits mean, same with the GWA, this would be mean. And in this question about difference, since you would be asking about the difference on gender and course, and for gender there would be two, then you would be using t-test. For course there would be many, then you should be using ANOVA. Okay, for motivation, study habits, whether they predict academic performance, all of them are interval data. But for you to answer that, this is a question of cause and effect, therefore you would be using regression as an analysis. By this, even in the conceptualization phase, you pretty much you have already a feel, you already have an overview of what to expect in the data analysis for your study. Okay, however, even if you already gathered the data, you have a valid and reliable instrument and others, sometimes the problem is on the encoding, on the tallying. Okay, what you should be mindful of is that when you try to encode, it should not be collective or aggregate. You should be utilizing spreadsheets for this, wherein the column labels, each label of each column corresponds to questionnaire entries. If your first question is about gender, then the label for that column is gender. If your next question is about educational attainment, the next label of a column is about educational attainment. If your next set of questions would be about motivation, then you label it as M1, M2, M3, depending on how many questions you have for motivation. That's how you should be writing your or encoding in your spreadsheet. If you would have non-numerical data, such as categorical data, you should be supplying codes for them, just like what we relayed earlier. Please do not forward to the statisticians tallying like this. Ano, parang nagsusurvey lang talaga na ilan ang sumagot sa inyo sa number 1 ng always. Ilan ang sumagot ng often. You should not be tallying like this. Mali po itong pagtatali. It would be a nightmare for a researcher or a statistician if you would be supplying them with this data and you would have questions that would require answering the hypothesis or accepting or rejecting the hypothesis. Okay, although this would be simulated, demonstrated in another recording, but I will be presenting results based on key questions. Kunwari, ang unang tanong natin is, we would want to compare the level of social well-being between males and females. So you're trying to do a comparison to groups. Another question is, yes, you're trying to compare, but for groups. It's because course, what would only be involved in this example are 4 courses. Okay? For correlation, what if we'll try to know whether there is a relationship between the level of usage of internet, I think, or of certain games and social well-being. Both of them are interval data and you would wish to correlate them. And when you talk of regression as an example, you would want to know whether bullying has influence over work productivity. Now, this would be sample results, but before that, you should try to keep in mind that when you test the hypothesis, you're actually trying to compute for the p-value, and you would be comparing it to the level of significance, which is 0.05 as acceptable level of significance for the social sciences. For test of difference, you would be using t-test. In this sample, we are just simply assuming that all the data are parametric or satisfies the assumption of normality and homogeneity of variance. If you would be doing t-test, okay, the first value that you would be looking, that p-value, is the Levin's test, so that you would know whether you would assume if there is equal variance or none. There would be 2 values for p-value as a result for t-test. For you to know which to use, you try to look first for the p-value for the Levin's test. For ANOVA, you look for the p-value. If the p-value is significant, then you should be doing post hoc. If it's correlation, look at the p-value first, compare it with the 0.05. If it is significant, then you should interpret the correlation coefficient, or what we call as R value, so that you would know the strength and direction of the results of your study. If it's for regression, the first thing that you should be looking to is the F value, so that you would know whether there is good model fit. If you could not satisfy this one, there's something wrong with your model. Then you try to look into the R-squared change. Okay, R-squared refers to the overall effect. If there would be more than one predictor variance, then you look into the p-value for each predictor, so that you would know which among them has a significant effect on a particular dependent variable, and so that you would know the amount of effect, the extent of effect one specific variable would have over another. Then you would look into the B coefficient. So these are just the general steps. What you would be doing is open the SPSS, look for the file in the data Excel sheet, click Analyze tab, click Compare Means, then choose the appropriate test. You would have to input the necessary items in there. Ililipat lang po yan sa box. Then you try to define the groupings if this is a t-test, which is in the example that you would be shown, it's utilizing t-test first for comparing two groups, and then you try to click OK. What would be the result would be like this. Okay, although this has already been reconfigured so that it would be presented this way, but say for example this would be the result. You could see here what you would be looking is the p-value, but in this case it's already being selected because the computation for Levin has already been done. Okay, if it's less than 0.05, and in this case only one has less than 0.05, therefore only one would be rejecting the HO. Therefore you are saying that with regards to the level of social being in terms of respect for others, males versus females vary significantly. Whereas the rest, males and females, basically have similar levels of social well-being in terms of cooperation, connection, concern, and the general social well-being. That's how you try to make an interpretation of the results. How about if it would be more than two groups? This is an example, and these are the courses involved in the study. Same other uh, variable, which is on the level of social well-being. You could see here the level of significance. Only two are less than 0.05, 0.025 and 0.15. Therefore, only in these areas that we could say that we should be rejecting the HO, or there is a significant difference. And based on post hoc analysis, those groups are only BS-ECE versus CPE, BS-Psych versus CPE on these areas. Whereas in the rest, there is no significant difference. Okay, how about in the question of correlation? Now, this would be an example of its result. Okay, what you would be looking first is on the sig, or in the p-value. P-value is also labeled as sig, or the significant. Okay, 0.049 is less than 0.05. Therefore, you reject the null. Same with this case, 0.041 is less than the 0.05, therefore reject the null. And when you say reject the null, you are saying that there is a significant relationship between, okay, in this case, social well-being versus level of usage. Another is there is also a significant relationship between respect for others and level of usage. Whereas in the rest, there is no significant relationship. Now, since there is a significant relationship, you should determine whether the relationship is positive or negative, and whether the relationship is very strong, strong, moderate, weak, and negligible. How would we know? You try to look into their Pearson correlation. This is also known as the R value. Since this is negative, you are saying that there is a negative relationship. A negative relationship would mean that once one variable goes up, the other variable goes down. There is an opposite direction or movement. The movement is on the opposite direction, or this way, if it's negative correlation. Therefore, there is a negative correlation between respect for others and level of usage. And the strength of the relationship is 0.145. 0.145 is only on the negligible area. So the general interpretation here is that there is a significant relationship between respect for others and level of usage. Furthermore, their relationship is described as negative, negligible. Okay, it would also be translated as there is a negligible relationship between respect for others and the level of usage we're in. Once the level of usage increases, there is a negligible chance for respect for others to decrease. That's how you interpret it. Same with social well-being. It also has a negative, negligible correlation versus the level of usage. Okay? How about in regression? When you try to look into regression, you try to look into first the F value. The F value should be less than 0.05. In this case, the F is 0.003, this one. Therefore, you have a good model. Then you would be looking into the R squared. The R squared is 0.215. you will be translating this, transforming this into percentage. This would become 21.5. Now, what does it mean? Work-related and person-related and physically intimidating bullying styles accounts to 21.5% change in the productive behavior of employees. Ganyan kalaki ang kaya niyang baguhin na kayang bullying na yan. That's what it tells us. As a whole kasi yan. Pero if you would want to look into individual effect, you try first to look into the sig. Ito yung p-value. Which among them has less than 0.05? If you could see in here, wala. Therefore, what you could say is, individually, if it's work-related alone, it does not have any significant effect on productive behavior. Kung siya lang mag-isa. If it's person-related alone, wala rin siyang epekto dahil this is greater than 0.05. Physically intimidating as a workplace bullying behavior also could not have a significant effect on productive behavior. But kung tatlong to ay present in the workplace, it would really have a significant effect on productive behavior, accounting to 21.5% effect or change in their productive behavior. Ganon po kalala ang epekto ng workplace bullying. Okay? So, as a review, try to keep in mind, in testing the hypothesis, p-value, compare it with 0.05. For t-test, you look first at the Levin's test, then the p-value. For test of difference involving many groups, not just two, p-value first. If the p-value is significant or is less than 0.05, then you do post hoc analysis. For correlation, if the p-value is significant, you try now to proceed to determining whether there is negative or positive correlation and what is the strength of their relationship. That would be determined by the correlation coefficient. If it's for regression, look first into the value of f as reflected also in that p-value for ANOVA. R squared would reflect the overall effect. P-value talks about the level of significance or whether there is significant effect per indicator, per predictor variable. The coefficient would tell us to what extent, if you would just try to take into account that sole predictor variable, to what extent will it have an effect on our dependent variable. Okay, so that would be it for this session. I will be recording another for the simulation of the actual computation for SPSS and Jamovi, since for Jamovi it's freeware and it is what I provided you with as an installer, but don't you worry, it would still yield relatively the same computation, maybe not the values in itself, but the results with regards to whether you accept or reject the null hypothesis. That would be it for now. Thank you and good day.